Surface area of this cylinder. Well, the cylinder is made up of two circles and a rectangle. So we have a circle on top. We have a rectangle running through the whole thing, and then we have a circle on the bottom. All right, that's what it's made up of. Well, that means I need to find the area of those two circles, and I need to find the area of that rectangle. Well, the area of the circle is pi r squared. Well, we know the radius. It says the radius is 3. So that's going to be pi times 3 squared, which equals 9 pi. But we also have a circle down here that's also 9 pi. So our two circles are going to equal 18 pi. All right, now we just have to figure out the rectangle. Well, it says that this object has a height of 15. So if I label this as 15, that would mean this also has a height of 15. Now I just need to figure out that width. How do I find the width of that rectangle? EJ. I find the circumference of that circle. And the circumference formula is 2 pi r, right? Yep. So in this case, it would be 2 pi times our radius, which is 3, which would equal 6 pi. So our rectangle area is just going to equal length times width, which would be 15 times 6 pi, which is 60 plus 30, so that's going to be 90 pi. So our total area are our two circles added to our rectangle, so that's going to be 108 pi. You got to know how to do that one pretty much in your sleep. All right, these aren't going to be the hard ones on the test. These will be the ones that are just straightforward. You better get through. Don't lose points on that stuff. Speaking of tests, you will get your test back today at the end of class. All right, let's start off with questions from the homework. Questions from 12.1, surface areas. EJ, maybe?
11.
Sure. Number 11. Oh, is that the barn one?
Yeah.
Okay. Do you have a specific question? So I know where to gear this, or?
Well, I think I split the complicated side up correctly.
Okay.
And I got 987. Is that right?
For total area?
Well, no. For like that one of those sides
Okay.
is 987 because, well, the big rectangle is 720.
Right. Let's go through and see if we have the same stuff. So I split apart that front and back. That front and back are these ones right here. These are the front and back right here.
Yeah.
So I started with our two triangles. Our two triangles would be 2 times 1/2, 12 times 2.5, which equaled 30 for me. And then the two trapezoids, I ended up with 504.
Ooh. Yeah.
So one trapezoid would be 1/2 12 times 12 plus 30. Because it's height times our base 1 plus base 2 divided by 2.
You're right, yeah.
And then multiplied by 2. And then we came up with 504. And then I said I had two big ones here, which would be that 24 times that 40.
Right.
Or 30.
Yeah.
Oh, that's here, yeah. We have two of those. That would be 140. So that would be the front.
Right.
Then our two sides would be that 40 by 24, and I have two of those. So that would be 1920.
Yeah.
So that's the total space that needs to be painted.
Yeah, okay.
And then our shingles were just that rectangle plus that tiny rectangle, and I multiplied that by 2 because it's the same thing on the other side. And that's the area that needs to get shingled.
Right.
So it's just two rectangles. One is a 15 by 40. One is a 6.5 by 40. We've got the 6.5 and the 15 from here, and the lengths are both 40 for those. Songha. I'm not painting the floor.
Floor.
Nope, we're just painting the walls.
Yeah, that makes sense.
In fact, it even says they're painting the exterior walls of their country farm home. So it does say it right in there that we're just painting the walls. EJ, is that good enough? You think you saw?
Yeah.
Okay, good. Remember, on the test, if you have something organized like this, and maybe you had a mistake here, at least I can catch it, and I can take like a half point off because I can see where your mistake was. But if you're someone that writes all over the place and then adds it up down here, you're more likely going to lose a lot more points because the longer it takes me to find your mistakes, the lower your score is, because I'm not going to spend a half an hour on someone's test because I can't read their writing and I don't know where they put this stuff. But if you organize it really nicely, then I can find your mistake really quickly and either know it's a big mistake or a little mistake. So EJ's was, maybe he just made a mistake on his trapezoids, but he had the logic behind it. I'm looking for the logic. Right, that's where most of your points are. Do you get the logic of what you're trying to do? All right, other questions from the homework? Question. Number 9. So number 9, we have basically a cylinder, but we have a hole cut through the middle of that cylinder. So on number 9, I need to come up with the top and the bottom, but our top and bottom are no longer circles. They are going to be annuluses, right? This is just a strip on top, a strip on bottom. So my two annuluses would be the big circle minus the small circle. So I did pi r squared minus the small pi r squared. I multiplied it by 2, so I had my top and my bottom. All right, then we have an outside cylinder we have to concern ourselves about. So right, when I wrap this around and I open it, it's just a rectangle, kind of like today's bell work. So I just need to get this outside rectangle. So I said my outside cylinder is going to be the circumference of the circle. That's the width of it. The circumference of that circle would be 2 pi times the radius. Well, my big circle has a diameter 8, so the radius would be 4. So I would have 9 times, so it's width times height. So we have 9 times that 2 pi times 4. And that's because this height right here is 9. Okay, so basically I'm saying, this height is 9, then I multiply it by the circumference of the circle, and that's the width of it. Then we have one more shape. We have that tiny rectangle that's right through the center of this. All right, same idea. The height is still 9 on that guy. So I have 9. Now I just need the radius of the small circle. The radius of the small circle will give me the width of that one. And my radius would be, since my diameter is 4 of my small one, my radius would be 2. That's where they got the 9 times 2 pi 2. So that one includes basically 4 pieces, right at the top, a bottom, the big rectangle, and the small rectangle on the inside. Does that all make sense? Cool. So
that's the area of surface area.
That's the surface area,
That's
correct.
The area like inside.
That would be volume. That's what we're going to get to today.
Oh.
So what this basically is how much paint I'd have to buy to paint on the outside. What we're going to talk about today is filling up this whole thing. That would be volume. Okay? So this is just outside. What two-dimensional objects construct it?
I just did it area of
Okay. All right, other questions? All right, then today we're going to get into what Songhao was just talking about. What is the total inside area? But we don't call inside area of a three-dimensional object area anymore. We call it volume. Volume is basically the area of a three-dimensional object, everything that's inside of it. I think that's what you're getting to, right? Well, you've already talked about volume before in other classes, where it's length times width times height. It just brings in that third dimension. So when I have a rectangle, I just go length times width. Well, to make it three-dimension, now we have to go forward into depth. In this case, we call it height. All right? That's all well and good when we're talking about boxes, when we're talking about Yeah, boxes, I guess, would be the best way. But it gets a little more complicated when you get to a shape like example A. I can no longer do length times width times height, because then I'd have to subtract out this, and I'd prefer not to do that. And when we get to this, I can no longer do length times width times height, because circles don't have length and width. They have a radius. And we have a height. Well, I can't just do radius times height. So a much better way to look at volume. Volume is, at its core, a base area, and then how many times is that base area stacked on top of each other? In other words, if you had like a plank of wood, and we stack it all the way up, I can figure out how much wood is actually there if I come up with the length and width of one piece of the woods and how high it's stacked up. I can come up with how much wood is actually there. That's what's happening here. We just get the area of the base and we stack it how many times it is. That's going to be its volume. So area of our base times our height will give us our volume. But if you look back at this, that's exactly what this formula is saying. Because length times width is the area of the base. Because our base here is a rectangle. And if I do length times width, I have area of my base, and then I just multiply it by its height. That is the easiest way to look at volume, is find your area of your base and multiply it basically how many times you need to stack it. All right, let's go through, I think we have 4 examples, and then you'll cut free. So example 1, we don't have a complete rectangular base. Instead, we have a base that's going to look something like this. Where I have like a little thing chopped out of it, and that is my base. That is on top, and that's on bottom. Well, we have some measurements for this. We have this was 8. This was 3. This is 5. We also have this whole length is 9. What is this little length right here then? Yeah, would be. It's going to be 6. Yep. And what's that total length on top? What's that total length on top? Devian? 12? Probably not 12. It's close.
My bad, I was looking at it.
Yeah.
3.
Oh, okay.
14.
What was that?
14.
Split the difference.
9 plus 5 is 14. Right?
13.
Okay.
Because, am I doing it wrong? No, yeah.
Oh, yeah.
yeah.
8 plus 5.
Yeah. It's 8 plus 5, not the 9 plus 5. I think you did the 9 plus 5, right? Yep. It'd be the 8 plus 5 gives us our 13. Okay, so we have 13. So if I had to come up with the area of this figure, what's probably a good idea is what we did back in the day, where we would, we'd split it up into 2 rectangles. So I could find the area of each rectangle. So we'd have a 6 by 5, so this would be 30 in here. This one right here would be our 9 times 8, which would equal our 72. So the area of our base, that area would just equal 72 plus 30, which is going to be 102. Now, that is the area of our 2-dimensional shape. Now we're going to think about, I'm stacking it a whole bunch of times. So we're kind of picturing this kind of like our example up here where I'm stacking it. And I'm seeing how many times I'd have to stack it. I'm only going to do a couple of these. These take forever to draw. But we're stacking it upon stack upon stack. I'll do one more. So we're doing something like that. That will get me my volume. If I multiply that area by how many of these I'm going to have stacked on top of each other, then I will have my volume. So your volume of this one is going to equal your base area times your height. Well, we already came up with our base area. We said that's 102. What is the height of this one? What would the height be? Yeah.
20.
Maybe the 20. Yeah, I'm going to stack it basically 20 times. So this right here is my height. So we're going to have 102 times 20. Oh, you don't have your hand up, do you? Okay.
No.
So what's our total area be? Libby? 2,040. Now, I don't have any units on here, but I want to get us in the habit of using units. So I'm going to put centimeters cubed to get used to being able to do centimeters cubed, because in your homework it definitely has units in it. So if I started with centimeters, we would end up with centimeters cubed. With volume, you use cubed. Our next one is a cylinder. We're finding the volume of it. So that means I need to find the base area and multiply it by its height. What shape is the base of a cylinder? What shape is the base of a cylinder? Sizer? It's a circle. So that is my base. Now the area of the circle last time I checked was pi r squared. So we're going to do pi times 14 squared. So what is the area of that circle? EJ?
196 pi.
196 pi. All right, now just remember what's happening here. I am stacking these circles up. I am stacking them up. Ooh, that got away from me on that one. So what is the height of this cylinder? What am I going to multiply that base by? Remember, if you are going ahead, I'm okay with that, but you better stay with us so you can answer questions. So what is the height of this? Jacob? 27. Guys, if we're not volunteering answers, I'm not going to give you all your stuff. You're going to have to we have to do this as a class. I get you can go back and forth. Okay, so our volume is going to equal our base area, which we said was 196 pi times 27. So what is our volume? Emma?
5,292 units.
Yeah, units squared. Let's call it, what? Cubed, yep. Let's call it feet. Let's go feet cubed on this one. But it would be units cubed, yes. Whatever units we have, we're going to say we're going to do it in feet. All right, so that's a cylinder. That's an oddly box shape. Let's get to a circle with a wedge cut out of it. Well, that means our top is a Pac-Man shape, where we have a circle, but we're going to take a bite out of it. That looks something like this. And they do give me that this wedge is 100 degrees. And they give me my radius is 6. Well, what I care more about is that this measure right inside here is 260 degrees, because this is a big old sector of a circle. So when I get the area of this, I'm finding the area of a sector. So our area of this one is going to equal, the sector is 260 degrees. That's the piece I want, divided by 360. And since I'm doing the area of the sector, I'm going to do the area of the circle. So that's pi r squared, which is pi times 6 squared. Well, that's going to end up giving me, 26 pi. So who can give me the volume of this entire shape then? Isaac? 260 pi, because our height was 10. So we do 260 pi times our height of 10. Remember, height is that 10. That 26 is our base area, which equals 260 pi. What do we didn't use meters yet. Let's go meters cubed. What is the shape of the base on this next one? Careful. What is the shape of the base of the next one? Sangha. It is a triangle. It is a triangle. If you said rectangle, you're not alone, and people will do this on the test. Note, if I would pick rectangle to be my base, if I would stack up a bunch of rectangles, it would look something like this, where I'd go across here. But I'm starting to construct something that's a box shape and no longer that rectangular shape. We'd actually be making an entire box. So instead, we're going to pick the triangle to be my base. Because if I pick the triangle, I can then say, okay, if I stack a bunch of triangles up against each other, they're going to make that exact same shape. So we are going to use a triangle. So let's pull out that triangle. It's got a height of 8, it is 90 degrees, and it has a hypotenuse of 17. So what is the base of this triangle? Zizer?
68.
60.
Well, I said,
Oh.
I said 1/2 of 8 times 17, but I don't really know if that works.
That won't work because that's not the height.
Yeah.
The height and base always are 90 degrees. So we need to find this missing thing here. So I do need to find that x Krupa.
15.
It's 15. How'd you get that?
I use the Pythagorean.
You can use the Pythagorean theorem. So we could go 8 squared plus x squared equals 17 squared. Or you could recognize that it's a Pythagorean triple. It is that h 15, 17. If you didn't remember your Pythagorean triple, just use the Pythagorean formula. Right? At the end of the day, it's going to work. This only saves you like 30 seconds. So either you know it's Pythagorean triple, or you go 8 squared plus x squared equals 17 squared and solve it, and you should get 15. Now we have the height and base, right? So it has to be a 90 degree to have the height and base. So the area of that guy, our area equals 1/2 our base times height, so that'd be 15 times 8. I would do 1/2 of 8, which is 4, times 15 is going to be 60. So now let's talk about our volume. Our volume is our base area, which is 60 times our height. What is the height of this one? What is the height of this one? Yeah, Hush.
21.
It is 21. It isn't the 8, it's that 21 because we are running this direction with the stacking. So in fact, we're kind of putting it on its head. So that is going to be 60 times 21. What is our total volume of this one? Labib.
1260.
Let's just go units cubed on this one. Pretend like I didn't have anything, so we'll go units cubed. That's it. That's volume in a nutshell. Yeah.
Isn't 60 for one of the triangles?
Yep.
So you only need one?
You only need one because we aren't doing area anymore. Area was I have to figure out all the pieces that make it up. Since I found out this was 60, I'm going to stack it 21 times so I'll reach the other end. So this takes care of this 21 takes care of all the little triangles I would stack up. So it takes care of both ends. So don't multiply it by 2 because you have 2 ends. This 21 takes account for all of the triangles that you'd build in it. Just like on this one, when I came up with this, that 27 here counts all the times as stacks. So it actually counts all the way up to the top. So we don't have to worry about multiplying by 2 on this one because I have a top and bottom. That's just with surface area. Good question. I'm glad you asked that. Other questions on any one of these 4? No? All right, then the rest of the time will be for you to work. I will hand out your tests, and I'll check your homework right after I hand out your tests.